Hello everyone. Greetings for the day, welcome to the tutorial on ISTQB foundation level. Firstly, we will discuss about the contents. Fundamentals of testing. Testing throughout the software life cycle. Static techniques. Test design techniques. Test management. Tools support for testing. Now we will discuss about part 1, which is fundamentals of testing. What is software testing? Software testing is a process of executing a program or application with the intent of finding the software bugs. It can also be stated as the process of validating and verifying that a software program or application or product meets the business and technical requirements that guided its design and development. In other words, software testing is an investigation conducted to provide stakeholders with information about the quality of the product or service under test. Software testing can also provide an objective, independent view of the software to allow the business to appreciate and understand the risks of software implementation. Test techniques include the process of executing a program or application with the intent of finding software bugs, errors or other defects, and to verify that the software product is fit for use. Software testing involves the execution of a software component or system component to evaluate one or more properties of interest. In general, these properties indicate the extent to which the component or system is under test. Software testing involves the execution of a software component or system component to evaluate one or more properties of interest. In general, these properties indicate the extent to which the component or system is under test. Therefore, it is the process of executing a program with the intention of finding errors. It can show the presence of bugs but never their absence. A good test case is one that has a high probability of detecting an undiscovered defect, not one that shows that the program works correctly. It is impossible to test your own program. As the number of detected defects in a piece of software increases, the probability of the existence of more undetected defects also increases. As now we have know about the testing and its need. Whenever we are testing something, we are checking whether it is fit for purpose. It is needed as humans make mistakes. Some of them are deadly. Test activities exist before and after test execution. Thought process and activities involved in designing early tests and review of documents helps to prevent defects. Objectives: finding defects, gaining confidence about level of quality, providing information for decision making. Now we'll talk about why testing is necessary. Software systems form an integral part of life, from business applications to consumer products. Software products that do not work correctly can lead to problems like loss of money, time or business reputation, injury or death. Let's have a look at testing through third party. When I can test my own work, why ask others to come and spot my flaws? We are good lawyers for our own mistakes, but very good judges of the mistakes of others. After that, we would know about how much testing is enough. It should take account of level of risk, including technical risks, safety aspects, business risks, project constraints such as time and budget. Testing should provide sufficient information to stakeholders to make informed decisions about release of software being tested or handover to customer. Now have a look at hierarchy of failures, which is error, defect/bug/fault and failure. Let's us discuss about software bugs. A software bug is a failure or flaw in a program that produces undesired or incorrect results. It's an error that prevents the application from functioning as it should. Most common reason for software bug is human mistakes in software design and coding. Important reasons for software bugs: miscommunication or no communication, software complexity, programming errors, changing requirements, time pressures. Poorly documented code. Software development tools. Obsolete automation scripts. Lack of skilled testers. Now have a look at SDLC, Software Development Life Cycle. The Software Development Life Cycle, SDLC, refers to a methodology with clearly defined processes for creating high-quality software. In detail, the SDLC methodology focuses on the following phases of software development: requirement analysis, planning, software design such as architectural design, software development, testing, deployment. Have a look at defects placement in SDLC. Now let's see costs of defects in SDLC. Here we discuss about software testing. The process consisting of all life cycle activities, both static and dynamic, concerned with planning, preparation, and evaluation of software products and related work products to determine that they satisfy specified requirements, to demonstrate that they are fit for purpose and to detect defects. Now we are taking about testing principles. Testing shows the presence of bugs. Exhaustive testing is impossible. Early testing. Defect clustering. The pesticide paradox. Testing is context dependent. Absence of error fallacy. Testing shows presence of bugs. Testing reduces the probability of undiscovered defects remaining in software, but even if no defects are found, it is not a proof of correctness. Exhaustive testing is impossible. Exhaustive testing means testing all combinations of inputs and preconditions. If we test all combinations, then testing time and cost will increase exponentially. Optimum amount of testing needs to be planned based on assessment of various factors, forex, risk, customer needs, etc. Early testing. Cost of defects increase exponentially across the SDLC. Hence, testing must start as early as possible in the software development life cycle. It is done to find as many early defects and fix them at a low cost. Defect clustering. 80% of the defects are found in 20% of the modules, hotspots. With experience, testers should be able to detect such buggy modules and test them early, so as to find a good amount of defects. The pesticide paradox. If the same tests are repeated over and over again, eventually the same test cases will no longer find new bugs. To overcome this, the test cases need to be regularly reviewed and revised, adding new and different tests to help find new defects. Testing is context dependent. Different kinds of software are tested differently. A safety-critical software is tested differently from an e-commerce site. A storage product is tested differently from an ATM machine's software. Absence of error fallacy. If the system built is unusable and does not fulfill the user's needs and expectations, then finding and fixing defects does not help. Now, we will understand about useful terminologies. Maintenance testing. When a system is operational, environment is often corrected or changed to improve performance. Verifying that no new defects have been introduced during development of the changes is maintenance testing. Debugging. Development activity that finds, analyses and removes the cause of failure. Retesting. Tester ensures that the fix resolves the failure. Test basis. All documents from which requirements of a component can be inferred. Test plan. Document specifying scope, approach, resources, and schedule of intended test activities. Now have a look at fundamental test process. Here we will understand the test planning and control. Test planning is understanding the goals and objectives of customers, stakeholders, and the project and risks which testing is intended to address. Also called mission of testing and determines scope of testing. Test control is the activity of comparing actual progress against plan and reporting status and deviations. Involves taking actions necessary to meet the mission and objectives of project. Now we will understand the test analysis and design. Testing objectives are transformed into test procedures. Involves reviewing test basis, prioritizing test conditions based on analysis of test items, designing and prioritizing high-level test, designing test environment setup and identifying any required tools. Here we will understand about test implementation and execution. Includes finalizing, implementing, prioritizing, environment preparation and execution of test cases. Tasks involves creating test data and writing automated test scripts. Verify test environment has been set up correctly. Updating bidirectional traceability between test basis and test cases. Execution and logging outcome of test execution and comparing actual with expected result. Reporting discrepancies as incidents. Repeating test activities as a result of action taken for each discrepancy. Let's understand about evaluating exit criteria and reporting. Includes assessment of test execution against defined objectives. Tasks involves checking test logs against exit criteria. Assessing if more tests are needed or if exit criteria specified should be changed. Writing a test summary report for stakeholders. Exit criteria, set of generic and specified conditions, agreed upon with stakeholders for permitting a process to be officially completed. Now we will talk about test closure activities. Involves collection of data from completed test activities to consolidate experience, test where and analyze facts and numbers. Tasks involves checking all planned deliverables have been delivered. Analyzing lessons learned to determine changes needed for future release and projects. Using information gathered to improve test maturity. Hand over testware to maintenance organization who will provide maintenance. Here we are learned about delivery and maintenance phase. Maintenance. Once the application is delivered, the customer will start using it. While using, if at all they face any problems, then that particular problem will be created as tasks. Based on the tasks, corresponding roles will be appointed. They will define the process and solves the problem. This process is known as normal maintenance. But some customers may request for continuous maintenance. In that case, a team of members will be continuously working in the client site in order to take care of their software. Here we are learned about delivery and maintenance phase. Delivery. Tasks, hand over the application to the client. Roles, deployment engineers, or installation engineers. Process, the deployment engineers will go to the customer's place, install the application into the customer's environment and hand over the original software to the client. Proof, the final official agreement made between the customer and company is proof document for delivery. Here have a look at degree of independence. Now we will move to the next chapter, which is testing throughout the software life cycle. Now, let's start with verification and validation. Verification, static testing. It is a disciplined approach to evaluate whether a software product fulfills the requirements or conditions imposed on them. Static testing is a type of a software testing method which is performed to check the defects in software without actually executing the code of the software application. Whereas in dynamic testing, checks the code is executed to detect the defects. Static testing is performed in early stage of development to avoid errors, as it is easier to find sources of failures and it can be fixed easily. The errors that can't not be found using dynamic testing can be easily found by static testing. Validation, dynamic testing. It is a disciplined approach to evaluate whether the final, as-built software product fulfills its specific intended use. Now have a look at V model. The V model is a SDLC model where execution of processes happens in a sequential manner in a V shape. It is also known as verification and validation model. The V model is an extension of the waterfall model and is based on the association of a testing phase for each corresponding development stage. Here we are discuss about advantage and disadvantage of V model. Advantage. As verification, validation, test management process is maintained, the outcome will be a quality product. Disadvantage. Time-consuming model. Costly model. Now, here we will discuss about V model, test levels. Component/unit testing, searches for defects in and verifies the functioning of software components, e.g. modules, programs, objects, classes etc., that are separately testable. Integration testing, tests interfaces between components, interactions to different parts of a system such as an operating system, file system, and hardware or interfaces between systems. System testing, concerned with the behavior of the whole system/product as defined by the scope of a development project or product. The main focus of system testing is verification against specified requirements. Acceptance testing, validation testing with respect to user needs, requirements, and business processes conducted to determine whether or not to accept the system. Component/unit/module testing. Searches for defects in, and verifies the functioning of software, e.g. modules, programs, objects, classes, etc., that are separately testable. Occurs with access to the code being tested with the help of test framework or debugging tool. Stubs and drivers are used to replace the missing software and simulate the interface between the software components in a simple manner. Involves programmer who wrote the code. Component/unit/module testing. Test basis includes component requirement, detailed design, code. In this slide we would know about integration testing. Tests interfaces between components, interactions to different parts of the system and interfaces between system. There may be more than one level of integration testing. 4x. Component integration testing tests interaction between S/W components and is done after component testing. System integration testing tests interaction between different systems and may be done after system testing. Test basis includes software and system design, architecture, workflows, use cases. Let's talk about Big Bang vs incremental integration testing. Big Bang integration testing. All components or systems are integrated simultaneously, after which everything is tested as a whole. Less time-taking activity. Ideal for short releases. Debugging and bug fixing can be complex. Incremental integration testing. All programs are integrated one by one, and a test is carried out after each step. Slower process. Suitable for longer releases. Debugging and bug fixing is simple. Now have a look at integration testing, which is top-down vs bottom-up. Let's discuss about system testing. System testing is a type of software testing that is performed on a complete integrated system to evaluate the compliance of the system with the corresponding requirements. In system testing, integration testing past components are taken as input. The goal of integration testing is to detect any irregularity between the units that are integrated together. System testing detects defects within both the integrated units and the whole system. The result of system testing is the observed behavior of a component or a system when it is tested. Concerned with the behavior of whole system/product. Test environment should correspond to final target or production environment. Includes tests based on risk or requirement specification, business processes, etc. System testing should investigate both functional and non-functional requirements of the system. System testing starts by using the most appropriate specification-based, black box, techniques for the aspect of the system to be tested. Now have a look through acceptance testing. Acceptance testing, in the context of the engineering and software industries, is a functional trial performed on a product or prototype before it is put on the market or delivered, to decide whether the specifications or contract have been met. It also makes sure the quality and design of the product meet both contractual and regulatory obligations in terms of functionality, usability, durability, and safety. Formal testing with respect to user needs, requirements and business processes conducted to determine whether or not a system satisfies the acceptance criteria. The goal of acceptance testing is to establish confidence in the system, part of the system or specific non-functional characteristics, e.g. usability, of the system. Test basis includes user requirements, system requirements, use cases, business processes, risk analysis report. Now we will talk about forms of acceptance testing. User acceptance test focuses mainly on the functionality, thereby validating the fitness for use of the system by the business user. Operational acceptance test is acceptance of the system by system administrators, like testing of backup/restore, disaster recovery, maintenance tasks, check of security vulnerabilities. Contract acceptance testing is performed against a contract's acceptance criteria for producing custom-developed software. Regulation acceptance testing is performed against any regulations like government, legal, etc. Let's talk about alpha and beta testing. COTS, commercial off-the-shelf, software often wants to get feedback from potential or existing customers before the product is put up for sale commercially. Alpha testing is performed at developing organization's site but not by developing team. Beta testing, field testing, is performed by customers at their own locations and report incidents to the organization. Types of testing. Functional, black box testing, test of what the system does. Focused on suitability, interoperability, security, accuracy, and compliance. Non-functional testing, testing the attributes of a component or system that do not relate to functionality, e.g. reliability, efficiency, usability, maintainability, and portability. Structural, white box/glass box testing, testing based on an analysis of the internal structure of the component or system. Most often used as a way of measuring the thoroughness of testing through assessment of coverage. Here we will understand about confirmation and regression testing. Confirmation testing. Confirmation testing or retesting, when a test fails because of the defect, then that defect is reported and a new version of the software is expected that has had the defect fixed. In this case we need to execute the test again to confirm that whether the defect got actually fixed or not. This is known as confirmation testing and also known as retesting. It is important to ensure that the test is executed in exactly the same way it was the first time, using the same inputs, data, and environments. Maintenance testing. Maintenance testing is done on the already deployed software. The deployed software needs to be enhanced, changed, or migrated to other hardware. The testing done during this enhancement, change, and migration cycle is known as maintenance testing. Once the software is deployed in operational environment, it needs some maintenance from time to time in order to avoid system breakdown. Most of the banking software systems needs to be operational 24/7 365. So it is very necessary to do maintenance testing of software applications. Regression testing. Regression testing is defined as a type of software testing to confirm that a recent program or code change has not adversely affected existing features. Regression testing is nothing but a full or partial selection of already executed test cases which are re-executed to ensure existing functionalities work fine. This testing is done to make sure that new code changes should not have side effects on the existing functionalities. It ensures that the old code still works once the latest code changes are done. Now we will move to the next chapter, part 3, Static Techniques. Here we will discuss about static testing. Static testing is a type of a software testing method which is performed to check the defects in software without actually executing the code of the software application. Whereas in dynamic testing checks the code is executed to detect the defects. Static testing is performed in early stage of development to avoid errors as it is easier to find sources of failures and it can be fixed easily. The errors that can't not be found using dynamic testing can be easily found by static testing. Have a look through review process and its phases, which is planning, kickoff, preparation, review meeting, rework, follow-up. Planning starts with a request for review by the author to the moderator. A moderator is often assigned to take care of the scheduling, dates, time, place, and invitation of the review. Also, checks entry criteria for the document. Kickoff, reviewers receive a short introduction on the objectives of the review and the documents. Also, to get everybody on the same wavelength and control time that needs to be spent on reviewing. Preparation, the participants work individually on the document under review using the related documents, procedures, rules, and checklists provided. Also, potential defects, questions and comments are noted. Review meeting. The meeting typically consists of the following elements, partly depending on the review type: logging phase, discussion phase, and decision phase. Also, severity of the defect is specified as critical, major or minor. Rework. Based on the defects detected, the author will improve the document under review step by step. Not every defect that is found leads to rework. It is the author's responsibility to judge if a defect has to be fixed. Follow-up. The moderator is responsible for ensuring that satisfactory actions have been taken on all logged defects, process improvement suggestions and change requests. Let's us understand about roles and responsibilities. Moderator leads the review. Responsible for planning the review, running the meeting and following up after the meeting. Author, person responsible for document to be reviewed. Reviewers/checkers/inspectors, individuals who after necessary preparation identify and describe findings. Scribe, document all issues, problems, and open points identified during meeting. Manager, decides execution of reviews and allocates time in project schedules. Let's talk about review types, which is walkthrough, technical review, inspection. Walkthrough. Meeting is led authors, often a separate scribe is present. Scenarios, dry runs, and peer group participation may be used to validate the content. Main purpose, learning, gaining understanding, finding defects. Technical reviews. Documented defect detection process that involves peers and technical experts. Ideally led by a trained moderator, and pre-meeting preparation by reviewers is required. More formal characteristics such as the use of checklists and a logging list or issue log are optional. Main purpose, discussing, making discussions, evaluating alternatives, finding defects, solving technical problems and checking conformance to specifications. Inspections. It is usually led by a trained moderator, certainly not by the author. It is used defined roles during the process. It involves peers to examine the product. Rules and checklists are used during the preparation phase. A separate preparation is carried out during which the product is examined and the defects are found. The defects found are documented in a logging list or issue log. A formal follow-up is carried out by the moderator applying exit criteria. Involves. No formal process. May take the form of pair programming or technical lead reviewing designs and code. Results may be documented. Main purpose, inexpensive way to get some benefit. Now we will know static analysis by tools. Objective is to find defects in software source code without actually executing the software and locate defects that are hard to find in dynamic testing. Typically used by developers before and during component and integration testing. Value is early detection prior to test execution. Early warning about suspicious aspects of code by calculation of metrics. Improve maintainability of code and design. Prevention of defects. Typical defects discovered by static analysis. Referencing a variable with an undefined value. Unreachable/dead code. Missing and erroneous logic. Overly complicated constructs. Programming standard violations. Variables that are not used or improperly declared. Security vulnerabilities. Now move to the next chapter, Part 4, Test Design Techniques. Let's learn identifying test conditions. The basis for the tests is called the test basis. It could be a system requirement, a technical specification, the code itself, for structural testing, or a business process. Sometimes tests can be based on an experienced user's knowledge of the system, which may not be documented. From a testing perspective, we look at the test basis in order to see what could be tested. These are the test conditions. A test condition is simply something that we could test. Now here, test design, specifying test cases. Test conditions can be vague and cover a large range of possibilities. Test cases should be specific and may or may not traverse multiple conditions at once. Once a given input value has been chosen, the tester needs to determine what the expected result of entering that input would be and document it as part of the test case. In addition to the expected results, the test case also specifies the environment and other things that must be in place before the test can be run, the preconditions. In this slide we will learn about test implementation, specifying test procedures. The next step is to group the test cases in a sensible way for executing them and to specify the sequential steps that need to be done to run the test. The document that specifies the executable order of the tests is called a test procedure, and is often also referred to as a test script. Writing test procedure is another opportunity to prioritize tests. For example, a test may create a new customer record, amend that newly created record and then delete it. These tests need to be run in the correct order, or they won't test what they are meant to test. Have a look, testing techniques. Now, learn about specification-based or black box testing techniques. Boundary value analysis. Boundary value analysis, BVA, is based on testing at the boundaries between partitions. We have both valid boundaries, in the valid partitions, and invalid boundaries, in the invalid partitions. Equivalence partitioning. The idea behind the technique is to divide, i.e. to partition, a set of test conditions into groups or sets that can be considered the same, i.e. the system should handle them equivalently, hence equivalence partitioning. Let's understand about specification-based or black box testing techniques. State transition testing. State transition testing is basically a black box testing technique that is carried out to observe the behavior of the system or application for different input conditions passed in a sequence. In this type of testing, both positive and negative input values are provided and the behavior of the system is observed. X of word processor. State, transition, and events predefined by rules of the machine. Here is the example of testing techniques. Specify minimum series of valid transitions to cover every state. ASS S1 S2 S4 S1 S3 ES. BSS S1 S2 S3 S4 ES. CSS S1 S2 S4 S1 S3 S4 S1 S3 ES. DSS S1 S4 S2 S1 S3 ES. Decision tables testing. Decision tables are used in various engineering fields to represent complex logical relationships. This testing is a very effective tool in testing the software and its requirements management. The output may be dependent on many input conditions, and decision tables give a tabular view of various combinations of input conditions, and these conditions are in the form of true, T, and false, F. Also, it provides a set of conditions and its corresponding actions required in the testing. Use case testing. A use case in testing is a brief description of a particular use of the software application by an actor or user. Use cases are made on the basis of user actions and the response of the software application to those user actions. It is widely used in developing test cases at system or acceptance level. Use case describes interactions between actors, users or system. Use cases description of particular use of the system by an actor. Here we will understand about structure-based or white box testing techniques. Structure-based test design techniques are a good way of generating additional test cases that are different from existing tests. They can help ensure more breadth of testing. Whenever we can count things and can tell whether or not each of those things has been tested by some tests, then we can measure coverage. Statement coverage. Decision coverage. Here is another example of structure-based or white box testing techniques. 1. Read A. 2. Read B. 3. C equals A plus 2 asterisk B. 4. If C 50 then. 5. Print large C. 6. End if. Statement coverage and statement testing. It is the assessment of percentage of executable statements that have been exercised by test suite. Statement coverage is a white box testing technique, which involves the execution of all the statements at least once in the source code. It is a metric, which is used to calculate and measure the number of statements in the source code which have been executed. Decision coverage and decision testing. It is the assessment of percentage of decision outcomes that have been exercised by test case suite. Decision coverage or branch coverage is a testing method, which aims to ensure that each one of the possible branch from each decision point is executed at least once, and thereby ensuring that all reachable code is executed. Here is another example of structural-based or white box testing techniques. Now, here we will understand about experience-based techniques. Error guessing. The test cases for finding issues in the software are written based on the prior testing experience with similar applications. So, the scope of the test cases would generally depend upon the kind of testing test analyst was involved in the past. The error guessing technique does not follow any specific rules. Exploratory testing. Exploratory testing is a type of software testing where test cases are not created in advance but testers check system on the fly. They may note down ideas about what to test before test execution. The focus of exploratory testing is more on testing as a thinking activity. Exploratory testing is widely used in agile models and is all about discovery, investigation, and learning. It emphasizes personal freedom and responsibility of the individual tester. Here we will learn about other testing. Visual testing. The aim of visual testing is to provide developers with the ability to examine what was happening at the point of software failure by presenting the data in such a way that the developer can easily find the information she or he requires, and the information is expressed clearly. Gray box testing. Gray box testing, American spelling, gray box testing, involves having knowledge of internal data structures and algorithms for purposes of designing tests, while executing those tests at the user, or black box level. The tester is not required to have full access to the software's source code. Manipulating input data and formatting output do not qualify as gray box, because the input and output are clearly outside of the black box that we are calling the system under test. Let's learn about test design essentials. Effective test design. Test cases cover all features. There is a balance between normal, abnormal, boundary and environment test cases. There is a balance between black box and white box testing. There is a balance between functional tests and non-functional tests. Finally, documented test cases. Effective test design is a key to success for many organizations and for the projects. Designing test cases gives you a chance to analyze the specification from different angles. You can repeat the same test cases. Someone can execute the test cases for you. Validate the quality of test cases. Estimate the quality of target software early on. Here is the tips for writing good test cases. Writing good test cases. Writing good test cases. It should be accurate and do what it is intended to test. No unnecessary steps should be included in it. It should be reusable. It should be traceable to requirements. It should be compliant to regulations. It should be independent, i.e., you should be able to execute it in any order without any dependency on other test cases. It should be simple and clear, any tester should be able to understand it by reading once. Now, keeping in mind these characteristics, you can write good and effective test cases. Tests only one thing. Always make sure that your test case tests only one thing. If you try to test multiple conditions in one test case, it becomes very difficult to track results and errors. Organize your test cases consistently. You can organize your test cases in many ways, however, you should always follow the same pattern to organize your test cases. Write independent test cases. Your test cases should not have dependency on other test cases, i.e. you should be able to execute your test case individually with having dependency on other test cases. Write small test cases. Always mention purpose of each test case clearly in test case. Following things should be kept in mind while writing test cases. Testability: easy to test. Use active case: do this, do that. System displays this, does that. Simple conversational language. Exact, consistent names of fields, not generic. Don't explain Windows basics. Order of cases follows business scenarios. Improving testability of test cases. The definition of testability is easy to test accurately. It takes to execute the test and whether the tester has to get clarification during the testing process. Accurately means that if the tester follows the directions, the result of pass or fail will be correct. Improving testability with language. Test steps should be written in active case, specifying exactly as what to do. Now move to the next chapter, Part 5, Test Management. Here we will discuss about test organization and independence. Benefits of independence includes: independent testers see other and different defects and are unbiased. An independent tester can verify assumptions people make during specification and implementation. Drawbacks include isolation from development team and isolation from business objectives. Developers may lose a sense of responsibility for quality. Let's learn about tasks for test leader and tester. Tasks for test leader, also called test coordinator, includes planning, monitoring, and control of test activities. Estimating time, effort, and cost of testing. Initiate the specification, preparation, implementation, and execution of tests. Introduce suitable metrics for measuring test progress. Ensure test environment is built up before test execution. Tasks for tester includes: create and review tests developed by others. Create test specifications, set up environment, and acquire data. Implement tests, execute and log the tests, evaluate results, and document deviations/incidents. Automate tests and measure performance. Here we will discuss about test planning and estimation. Test plan. Document describing scope, approach of test activities and identifies features to be tested, degree of tester independence, tools used, if any, etc. Tasks includes: determine the scope, risks and identify objectives of testing. Determining overall approach of testing, including entry and exit criteria. Making decisions about what to test, how test activities should be done and scheduling test analysis and design activities. Entry criteria, the set of generic and specific conditions for permitting a process to go forward with a defined task. Exit criteria, the set of generic and specific conditions, agreed upon with the stakeholders for permitting a process to be officially completed. Test estimation. Test estimation is a management activity which approximates how long a task would take to complete. Estimating effort for the test is one of the major and important tasks in test management. Here we will learn about test monitoring, reporting and control. Test progression monitoring. Test monitoring in test execution is a process in which the testing activities and testing efforts are evaluated in order to track current progress of testing activity, finding and tracking test metrics, estimating the future actions based on the test metrics and providing feedback to the concerned team as well as stakeholders about current testing process. Test reporting. A test report is an organized summary of testing objectives, activities, and results. It is created and used to help stakeholders, product manager, analysts, testing team, and developers, understand product quality and decide whether a product, feature, or a defect resolution is on track for release. Test control. Test control is about guiding and corrective actions to try to achieve the best possible outcome for the project. The specific guiding actions depend on what we are trying to control. Here we will learn about risk and testing. Risk is the possibility of an event in the future, which has negative consequences. We need to plan for these negative consequences in advance so we can either eliminate the risk or reduce the impacts. Project risks. Risks that surround the project's capability to deliver its objective. Organizational factors. A. Skill, training, and staff shortage. B. Problems with tester communicating test results. C. Other high-priority tasks. Technical issues. A. Test environment not ready on time. B. Ambiguous requirements. Supplier issues. A. Failure of third party. Product risk. Product risk is the possibility that the system or software might fail to satisfy or fulfill some reasonable expectation of the customer, user, or stakeholder. Some authors also called the product risks as quality risks as they are risks to the quality of the product. Let's learn about incident management. Incident report is a document reporting on any event that occurred during the testing, which requires investigation. Objectives include: provide developers and other parties with feedback about identification of problem. Provide test leaders means of tracking the quality of the system. Must include summary, incident description, inputs, expected results, actual results, anomalies, date and time, procedure step, environment, attempts to repeat, testers and observers. Impact. Now move to the next chapter, Part 6, Tools Support for Testing. Here we will learn about tools support, testing. Test tools can have many purposes like improve efficiency by automating repetitive tasks, supporting manual activities like test control, generating test summary report, managing defects, support review process and monitoring. Automate activities that cannot be done manually. Tools can be used for many activities like directly used such as test execution tools, test data generation tools and result comparison tools. Managing test process like manage test results, data, requirement, incidents, reports, etc., and for reporting and monitoring test execution. It can be any tool that aids in testing, e.g. spreadsheet. Now let's learn about test management tools. Test management tools are used to keep track of all the testing activity, fast data analysis, manage manual and automation test cases, various environments, and plan and maintain manual testing as well. The test management tool is connected with the automation software. These types of tools had various strategies for testing and multiple sets of features. Some of the test management tools had capabilities to design the test case with the help of requirements. Managing the testing process. Scheduling of tests to be executed. Traceability of tests and logging test results. Preparing progress reports and tracking defects. Requirement management tools. Since the tests are based on requirements, the better the quality of the requirements, the easier it will be to write tests from them. It is equally important to be able to trace tests to requirements and requirements to tests. Some requirements management tools are able to find defects in the requirements, for example by checking for ambiguous or forbidden words, such as might, and /or, as needed or, to be decided. Features or characteristics of requirements management tools are: to store the requirement statements, to store the information about requirement attributes, to check consistency of requirements, to identify undefined, missing or to be defined later requirements, to prioritize requirements for testing purposes, to trace the requirements to tests and tests to requirements, functions, or features, to trace through all the levels of requirements. Interfacing to test management tools. Coverage of requirements by a set of tests, sometimes. Incident management tools. An incident management tool enables IT teams to categorize, organize, and resolve major incidents that result in downtime or service interruptions. It sits at the center of an IT organization's ecosystem and delivers real-time alerts to the right teams on their phones when an incident is detected. It aids in the labeling of incidents and can be seamlessly integrated with existing technology stack and workflows to accelerate incident resolution. Configuration management tools. Configuration management is the practice of cataloging and tracking the physical and virtual systems within an organization as well as the metadata for these assets. In software development, configuration management is used to optimize application configurations for their production environments to avoid downtime. Now, we will learn about tool support, static testing. Provide a cost-effective way of finding more defects at an earlier stage. Review tools. Storing review comments. Communicating comments to relevant people. Keeping track of comments. Repository for rules, procedures, and checklist to be used. Static analysis tools. Used by developers to find defects prior to dynamic testing. Enforce encoding standards. Identify anomalies in the code. Here we will know tool support, test execution, and logging. Test execution tools, example, Selenium. Also known as capture/playback tools, capture/replay tools or record/playback tools. Use a scripting language to drive the tool. Closely tied to the flow and interface presented by the GUI. Capture test inputs and stores result in the form of screen or object to compare. Test harness/unit test framework. Provides stubs and drivers. Supplies inputs and receives outputs generated by the software. Recording result of each test. Support for debugging. Used by developers. Let's understand about tool support, test execution, and logging. Test comparators. A test comparator helps to automate the comparison between the actual and the expected result produced by the software. Post-execution, compares content of entire file with expected outcome of that file. Dynamic comparison of events that occur during test execution. Security tools. Identifying viruses. Detecting intrusions such as denial of service attacks. Simulating various types of external attacks. Probing for open ports or other externally visible points of attack. Identifying weaknesses in password files and passwords. Coverage measurement tools. Measure the percentage of specific types of code structure, e.g. statement or decision. Now we will learn about tools support, performance, and monitoring. Dynamic analysis tools, D. Dynamic analysis is the process of testing and evaluating a program while software is running. Also referred to as dynamic code scanning, dynamic analysis improves the diagnosis and correction of bugs, memory issues, and crashes of an application during its execution. Require the code to be running. Detects memory leaks, identifying null pointers. Performance/load/stress testing tools. Load testing is a type of performance testing that simulates a real-world load on any software, application, or website. Without it, your application could fail miserably in real-world conditions. That's why we build tools like Retrace to help you monitor application performance and fix bugs before your code ever gets to production. Load testing examines how the system behaves during normal and high loads and determines if a system, piece of software, or computing device can handle high loads given a high demand of end users. This tool is typically applied when a software development project nears completion. Generating load and measuring time of specific transactions. Producing graphs or charts of responses over time. Purpose is to measure response time or throughput. Monitoring tools. Monitoring tools are used to continuously keep track of the status of the system in use, in order to have the earliest warning of failures, defects, or problems and to improve them. There are monitoring tools for servers, networks, databases, security, performance, website and internet usage, and applications. Keeps track of the status of the system. Analyze, verify, and report on usage of specific system resources. Monitoring network traffic and sends alert to administrator. For servers, network, database, security. Here is some benefits and disadvantage of using tool. Pros. Reduction of repetitive work. Greater consistency and repeatability. Objective assessment. Ease of access to information about tests or testing. Cons. Unrealistic expectation for the tool. Underestimating the time, cost, and effort for initial introduction and to achieve significant and continuing benefits from the tool. Neglecting version control of test assets generated. Over-reliance on the tool. Risk of tool vendor going out of business. Here we will learn about introduction a tool to an organization. Important considerations. Organization's maturity and readiness. Identify areas where tool support will improve testing process. Evaluation of the vendor, training, support, and other commercial aspects, or open source network of support. Identifying and planning internal implementation, including coaching and mentoring for those new to the use of the tool. Estimation of cost-benefit ratio.